Hello, welcome to Mathematics with Simon. I'm Simon. Today we're going to look at the factor theorem, which is an A-level mathematics subject. So what is the factor theorem? It says given a polynomial p of x, then x minus a is a factor of p of x if and only if p of a equals 0. So there's two ways of thinking about this. The first is this demonstrates a relationship between the roots of a polynomial and its factors. We can also think of it as a special case of the remainder theorem in which the remainder is 0. We did a video on the remainder theorem. I'll put a link in the description. So for example, p of x equals x squared minus 5x plus 6. So we can see by just straight division that x minus 3 is a factor of x squared minus 5x plus 6. We can also see that x minus 2 is a factor. So we can write it like this: x squared minus 5x plus 6 equals x minus 2 times x minus 3. And actually you could have just done that by straight quadratic factorization. It wasn't necessary to do the long division, but still long division is nice. We've got a video on that too. I'll put a link in the description to that too. But we can just write that as a straight factorization. And then what we see is if p of x equals x squared minus 5x plus 6, if we put in 3, we get 9 minus 15 plus 6, which is 0. And if we put in 2, we get 4 minus 10 plus 6, which is also 0. Let's look at another example. Polynomial of x equals x squared minus 4 equals x minus 2 times x plus 2. And so what we should see is, by the factor theorem, we should see that if you put in x is 2, you get 2 squared is 4, minus 4 is 0, and you put in x is minus 2, you get minus 2 squared minus 4 is also 0, so 4 minus 4 is also 0 because minus 2 squared is 4. Here's another example, which is kind of fascinating. P of x equals x squared minus 4x. Now you can factorize that as x times x minus 4, or x minus 0 times x minus 4. So by the factor theorem, we'd expect to see 0 when we put in x as 0, which just gets 0 minus 0, which is 0. And also we'd expect to see 0 when we put in x as 4. So in this case, you get 16 minus 16, which is also 0. So that's also working. So let's just look at the proof of the factor theorem. So the factor theorem says, given a polynomial p of x, x minus a is a factor of p and x if and only if p of a equals 0. X minus a is a factor of p of x if and only if p of a equals 0. So firstly, let's assume that x minus a is a factor of p of x. Now we've got to prove that p of a equals 0. Well, if x minus a is a factor, that means the remainder when we divide p of x by x minus a must be 0. That's by the definition of a factor. And in that case, p of a must be 0 by the remainder theorem, which proves what we were setting out to show. And we start from the other side. Let's assume that p of a equals 0. Then that tells us that the remainder when we divide by x minus a is 0 by the remainder theorem. So x minus a is then a factor of p of x by the definition of a factor. So basically what we've done is we've used the remainder theorem and the definition of a factor to prove the factor theorem, which kind of shows that the factor theorem is a special case of the remainder theorem. Here's a big example. P of x equals 2x cubed minus 3x squared minus 3x plus 2. And we can actually factorize that as x minus 2 times x plus 1 times 2x minus 1. So if we put in x as minus 1, we get minus 2 minus 3 plus 3 plus 2, which is 0. If we put in x as 2, we get 2 times 8, which is 16, minus 12, minus 6, plus 2, which again is 0. And then finally, this last term, 2x minus 1, what we need to do here actually is, because we've got a coefficient of the x, so the coefficient of the x is not 1, we've actually got to put in 1 divided by 2. We've got to put in the number at the end divided by the coefficient. So we've got to put in a half. When you put in a half, you get 2 times an eighth is a quarter, minus 3/4 gives you minus a half, minus another 3/2 from the x term gives you minus 2, plus 2 comes to 0. So we've got a new version of the factor theorem here, which we showed on this last term, which says, given a polynomial p of x, then bx minus a is a factor of p and x if and only if p of a over b equals 0. So in the previous example, b was 2 and a was 1, and p of a half was 0. And this is actually a generalization of the factor theorem, because in the case when b equals 1, you just get p of a equals 0, and it's the same theorem. So I hope you like this video. If you do, please hit the like button. That helps. You're very welcome to subscribe and hit the notification bell. We'd love to hear your ideas. We appreciate all the ideas we've been sent, and I hope you enjoy your mathematics. That's the most important thing.